Hey there everybody, today we're going to be talking about graphing systems of equations. The good news is if you can graph a line, then you can solve a system by graphing. So what is a system of equations? A system of equations is just two equations like this. And what does it mean to solve the system? That means you're looking for the one set of x and y values that works for both equations. Okay, so first I'm going to just show you the how. I'm going to show you how to solve problem number 1. When we get to problem number 2, I'm going to show you a little bit why that works, and then we're going to do just a bunch more examples. Please make sure you continue watching this video at least until problem number 4, because this one works a little bit different and you need to know how to do that too. Okay, let's get started with number 1. Alright, so number 1, we have two equations in slope-intercept form, so let's graph them, and then I'll show you what to do next. So first equation, y equals 3 over 2x plus 4. Here's our starting point. 4 is the y-intercept, so let's go ahead and put that on the graph. And then let's use our slope to figure out the next point. So we need to go up and over 3. Well, we can't do that. So instead of going up 3 and over 2, we're going to go down 3 and to the left 2. The key here is just to make sure that your line is going uphill once you're done. And I'm just grabbing a straight edge here. I've got my little Village Baker gift card here. I need my straight edge to make sure I draw a nice straight line. And then you connect your dots like that. And now let's graph the second equation. Here we have y equals negative 1/4 x minus 3. So again, our starting point here on the y-intercept is negative 3. And now we use our slope, negative 1 over 4, to figure out where to put the next point. So we need to go down 1 and over 4. There we go. And if we wanted to, we could go up 1 and to the left 4. That would work too. We, again, just have to make sure that since we have a negative slope, our resulting line goes downhill. And it looks like this one does. Let me go ahead and connect the dots like this. Okay, that's the main part of it. You're almost there. You have one more step to solve this system of equations. Where do the lines cross? Where do they intersect? Right here, right? That is the point that you need to write down as your solution. So we need to write this down as an ordered pair. Let's figure out what that is. Let's figure out our x value first. So it looks like we go over negative 4 and down 2. So we need to write negative 4 for the x and negative 2 for the y value. And that's how you solve it. You just graph both lines, you figure out the point where they cross, and you write it down as an ordered pair. Now you may be saying, why? What does this all mean? We're going to talk about that a little bit more in problem number 2. So let's look at problem number 2. I want to start with the other equation. We're going to start with the one on bottom. It really does not matter which order you graph these in first. So do whichever one first. I'm going to start with this one. Y equals x plus 2. So our y-intercept is 2. Let's go ahead and get that on there. And our slope, there's nothing in front of the x, so we know that it's just a 1. So we're going to go up 1 and over 1, and you could write as many dots as you want to, and then we're going to just connect that with a nice line. Okay. So now before we worry about putting the other graph on before we put the other equation on the graph, you know what I mean, let's talk about what this line means. Why does this equation turn into this line to begin with? Well, this line is just a visual representation of all the possible answers to this equation. So, like for example, what if x was equal to 1? What if we said x was equal to 1? Well, let's see. 1 plus 2 equals 3. So if you plugged 1 in for x, your y would equal 3, right? Well, look down here. You have 1 for x, and what is your y equal to? 3. Okay, that's right there on the line, right? What if you said your x was equal to negative 5? So if you plugged in negative 5 for x here, and then you add 2 to that, you get negative 3. So y equals negative 3 if you plug that in. Let's see if that works with our graph too. Oops, let me move that over. So x equals negative 5. Let's see what the y equals at that point. Look at that, negative 3. Now what if you chose an in-between point on this line? What if you went with like 0.5 for x? You know what? Guess what? Your answer would be 2.5 for y. Every point on the line even the in-between ones, show this relationship between x and y. And any one of these points, there are like infinite numbers of them, any one of these points satisfies this equation and makes a true statement. So this line, again, is the representation of all the correct answers for this equation. Let's go ahead and put the other equation on there. So y equals 7x minus 4. So we're going to go down to -4, that's the y-intercept, and now let's graph our slope. 7 over 1, 1, 2, 3, 4, 5, 6, 7, and to the right 1. Well, it looks like it's right on that dot. Let me go ahead and connect them. Like this. Okay. So now what does this new line represent? Every point on this new line is a solution to this equation right here, right? And again, there's infinite number of solutions to this equation. But what if I was looking for the one set of x and y values that make this equation and this equation both true? No longer do we have infinite solutions anymore. In this case, we only have one solution, and it's where they cross. There's only that one point where the lines overlap each other, and that is going to tell us the answer, the solution to the system of equations. And in this case, you can see where it is. Let's write it as an ordered pair. It's where x is equal to 1 and y is equal to 3. So that means if you plug 1 into both of these equations, the answer you're going to get out is going to be a 3. We already tried that in the bottom one. Let's try it in the top one. 7 times 3 minus 4. So that's going to be 21 minus 4. And that is going to equal, it's not 3. What am I doing wrong here, guys? Yep. Do you see what I did wrong? I plugged the y into there instead of the x. So sorry about that. Let me try it again. You're going to plug the x value in here, which is 1. So 7 times 1 minus 4. So simplify that, you get 7 minus 4, which equals 3, which is exactly what it's supposed to equal. All right, so that was the why it all works. Let's go on and do a bunch more examples now. Like I said, make sure you hang on at least until the end of example 4, okay? Because you need to know how to do this stuff. And here we are on number 3. So we have y equals -5 over 4x minus 4. This is our y-intercept. Let's start with that. -4. Our slope is -5 over 4. So I want to go down 5. Wait a second, I can't do that. If I can't, I just need to go up and to the left. So let's do that. 1, 2, 3, 4, 5. And to the left, 1, 2, 3, 4. And now we create our line. And if you have to reverse and go the other way, kind of like I just did by going up and left, if you have any doubts about whether or not you went the right way, just make sure your line is going either downhill or uphill, whichever you want it to do. In this case, we have a negative slope, so I definitely want it to go downhill, and that is what it's doing, so we're in good shape. Let's graph our next line. X equals -4. Okay, so let's go to our x-axis and find -4 right here, and then we're just going to draw a line vertically through that. Like that, and then where is our solution? It's where they cross, right? Right here. So our solution is -4, 1. And you're just going to write it right like that. Okay, let's do this special one, number 4. You'll see why it's special as we start solving it. Okay, so we have y equals -4x plus 4. Start with that y-intercept, put it on the graph. Now, -4 is the slope, which is the same thing as -4 over 1. So we're going to go down 4 to the right 1. Down 4 to the right 1. And let's draw the line by connecting the dots. Okay, now we have -4x minus 3. So we're going to start at -3. That's the y-intercept there. So -3. And now we have -4, again, -4 over 1. So let's count, I can't go that way, so let's go up and over to the left. 1, 2, 3, 4, and to the left 1. 1, 2, 3, 4, and to the left 1. Okay, and let's connect those. Now, look at this. Where do these lines cross? They actually are not crossing. In fact, they're parallel, right? And do you guys remember what it is about parallel lines? they never cross. They will go straight forever and ever and never cross each other. So if you get a graph that looks like this, your solution is no solution. And that's all you have to write. Okay? So in this case, you would have no solution. Now, if you had the two lines totally on top of each other, then you would have infinite solutions. But when they have the same slope and they're in different places, so they're parallel, then it is no solution. Okay, we got 4 more examples. If you want to watch them, then stay tuned. Let's do number 5. Okay, y equals x plus 2. Let's get our y-intercept on there first. There we go. And then the x, so what's the slope in front of the x? It's just a 1, right? So 1 over 1. And you can put as many of these dots as you want to on there, and then just connect them for a nice line. And for x minus 1 for the next one, so this y-intercept is -1, and the slope is 4. I'm going to go up 4, 1, 2, 3, 4, and over 1. And then let's go down 4 and over 1 the other way, just making sure my line goes uphill, right? And looks like we're going to go like that. Now what's the solution? It's going to be where they cross, right there. Just remember to write it with the x first. The x value is a 1, and then the y value is a 3. Okay, let's look at number 6. Start out with y equals 2. This one's kind of different. You have to look at the y-axis and find the 2, which is right here, and then draw your line going across through the axis. Okay, and then y equals -x minus 2. So your y-intercept is this, the -2, so find -2 here. And your slope is -x, so that's the same thing as like -1x. So you're going to do -1 over 1 for your slope. So you're going to go down 1 over 1, and you're going to make sure your line is going downhill because that slope is negative. And then just connect the dots, make sure you're staying nice and straight so that you have an accurate solution. And where do they cross? Looks like right here. And what is that called in terms of an ordered pair? It looks like that's -4, 2. Okay. Whoops, let's get that on there. There we go. -4, 2. Okay, we've got 2 left. Let's do number 7. If you want to pause the video and try this by yourself and then check back and see if you got it right, I think that'd be awesome. So your y-intercept is 1 for this first equation, and your slope is 1 over 3, 1/3. So you're going to go up 1 over 3. And then if you want to go back the other way for another dot, you can do that also. And connect your lines, making sure our slope is uphill because it's a positive slope. And for our second line, we're going to start at -4. And our slope is 2, which is the same thing as 2 over 1. So we're going to go up 2 over 1, up 2 over 1, like that. And connect our dots. Got a little messy there, sorry. And then the overlap here is right there. What is our ordered pair for this? Looks like it's 3 for the x and 2 for the y. 3, 2. Did you get it? Good work. Okay, let's go on to the last one, number 8. Okay, y equals 2x minus 3. So the -3, let's graph that. That's our y-intercept. And then the slope is 2, 2 over 1. So up 2 over 1. Do-do, 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 like that. And then you connect your dots. Okay. And now what about the second line? Why, well, wait a second. That's exactly the same, isn't it? So you would start at -3, you go up 2 over 1. Now all the points that I would put on are the same. In fact, the entire line is the same because, as you can see, whoops, so sorry, it's the exact same equation. So when you have the same equation and basically 2 lines on top of each other, every single point along the line is a solution for both equations. And there's an infinite number of these solutions. So you're going to put infinite solutions. Or you could use the infinity sign if you want, like that, however you want to do that. So that's how those are solved. If you have any questions, ask your teachers. We love to help, and thanks for watching. Bye.